Hello everyone, in this video I'll be talking about dividing polynomials. So let's start with the simple topic. Simplify 4 divided by 14. So let's pause the video and simplify this. Okay, so I think you guys are done simplifying this, so let's do this. So I'm gonna do 2 times 2 and I'm gonna do 2 times 7. We already did this, so you should know this already. And then I can cancel the 2's. If I cancel the 2's, that means I'm going to get a 1. And if I have a 1 times 2 is just 2, and 1 times 7 is just 7. That means I have 2 over 7, or 2 divided by 7. We already know this, right? Okay. So now let's look at a different scenario. Let's say I'm going to simplify 3 divided by 6. And I'm going to write 2 plus 1, and I'm going to do 2 plus 4, and I'm going to cancel the 2's, and I'm going to say, okay, this is 1 divided by 4. Now, do you guys agree with this, that 3, let me write this here. So what I did here is 3 over 6, and I said, after simplifying this, we actually got 1 divided by 4. Is this true? Is 3 divided by 6 equal to 1 divided by 4? Okay, so let's look at the first scenario when we did this. So let's do this using this method. So I'm going to do 3 times 1, and I'm going to do 3 times 2. Cancel the 3's, and I can see this is half. Okay, so 3 over 6 is actually half. But if we do it this way, we are actually getting 1 over 4. And 1 divided by 4 is not equal to half. That's not equal. So we cannot do this. Let's change the color. We cannot do this. This is not possible. We cannot say 2 plus 1 divided by 2 plus 4. Okay, that is not acceptable. Okay, and one more thing, when we did 2 times 2, we are actually factoring 4, and when we did 2 times 7, we are actually factoring 14. And we did the same thing here. So when we wrote 3 times 1, we factored 3, and 6, we factored 6 3 times 2. When we are factoring, and when we have a common factor, the top and the bottom, then we can cancel them. Okay, we can cancel the common factor when they're being multiplied in both denominator and the numerator. Okay, because remember, factoring is rewriting a quantity as multiplication. So you are rewriting 3 into 2 numbers, 3 and 1. 6, you're doing 3 times 2. Only in this case we can cancel them, because look at the operation here. This is multiplication. Okay, and multiplying something by 1 will not make a difference, but here we are adding them. Okay, when you're adding them, they're not factors of 3 or factors of 6. Okay, so that's why we cannot do that. So this is very important to understand. So we cannot do 2 plus 1, 2 plus 4, and say, I mean, we can, 3 is actually 2 plus 1 and 6 is actually 2 plus 4, but we cannot cancel the 2's in this case. Okay, all right, so let's look at a different scenario now. Let's erase everything. Okay, so now 8 is equal to 2 times 4. That means 2 and 4 are the factors of 8. Okay, so now let's say 2x. 2x means it's 2 times x. So using the same principle that we did here, 2 times 4 is 8, and 2 and 4 are the factors of 8. We can say that 2 and x are the factors of 2x. Again, you are factoring 8. Factoring means rewriting the quantity into multiplication. So we're multiplying 2 times 4 and saying 2 times 4 is 8. That's why 2 and 4 are the factors of 8. Same thing here when you have 2x. That means actually 2 times x. That means 2 and x are the factors of 2x. Okay, similarly, if I say negative 5x, I can say negative 5 times x. That means negative 5 and x are the factors of negative 5x. Okay, let's look at some other scenarios now. Oh, before I move to another slide, 2x is a term, and if you guys remember, this is called a monomial because it's just one term. Now we're going to look at a binomial. So let's erase this. Okay, so let's say I have, let me write that one more time. So 8 is 2 times 4, and 2 and 4 are the factors of 8. Now I'm going to write a binomial, 2x plus 20. How do I factor this? So factor this, pause the video and come back in a second and see if you get the right answer. So 2x, I'm going to write 2 times x. I'm going to do 2 times 10. We already did this, so I'm not explaining this again. And then 2 is common, so I'm going to do 2 and x plus 10. Now this is very important to understand. Like the way we said 2 times 4, or let's say 2 times x. Remember, factoring means rewriting the quantity in multiplication. So 2 and 4 are the factors of 8. 2 and x are the factors of 2x. In a similar way, when I look at this binomial 2x plus 20, this can be rewritten as 2 times. Remember, this is multiplication. You're multiplying 2 and x plus 10 as a whole. This thing as a whole are being multiplied with 2. So I can say that 2 and x plus 10 are the factors of 2x plus 20. Okay, this is very important to understand because most of the students get confused here that why it's 2 and x plus 10. Remember, the definition of factoring means you are rewriting the quantity as multiplication, not adding, not subtracting, but multiplication. So 8 is 2 times 4. That's why 2 and 4 are the factors of 8. 2x, 2 times x. That's why 2 and x are the factors of 2x. Similarly, when I have 2x plus 20 and I factored this and I got 2 times x plus 10. Condition for factors are that the two quantities, the 2 and x plus 10 are being multiplied. This is why 2 and x plus 10 are the factors of 2x plus 20. Okay. If you're still a little confused, I will ask you to watch this part of the video again. That will help you. So let's look at another example. So I'm going to write another binomial, x squared plus 4x. Again, pause the video and factor this and see if you get the right answer. So I'm going to do x times x, 4 times x. X and x are the common factors. So x and x plus 4. So we are done factoring x squared plus 4x. Now look at the two quantities here. What are being multiplied here? X, the multiplication sign is here. So x and x plus 4 are being multiplied. This is why x and x plus 4, x and x plus 4 are the factors of x squared plus 4x. Okay, make sure that the 4 itself is not a factor, because you can see x squared and 4x doesn't have 4 as a common factor. So we cannot say 4 is a common factor. It has to be x plus 4. Okay, and then this is x because x is common here. Okay, that's why x and x plus 4 are the factors of x squared plus 4x. Okay, so I hope this makes sense. How do we find factors of meal? All right, so now let's look at a problem. Remember, today's topic is dividing polynomials. So let's look at a problem now. So if you understand this so far, let's simplify 2x plus 6 divided by 5x plus 15. Okay, so can we cancel the x? Okay, so here there's some confusion. Some of you might say, okay, I can cancel the x. Some of you say, no, I cannot cancel the x. So before I do this, let's do a problem. Let's say I'm going to do 6 divided by 8, and I'm going to do 2 times 2, 4. 2 times 2 is 4, plus 2, which is 6. And I'm going to do, let's say, 3 times 2, which is 6, and plus 2. Now, can I cancel the 2's here? Okay, let's see. I can cancel the 2. Let's see what happens if I cancel the 2's. If I cancel the 2's, I have 2 plus 2, which is 4, and 3 plus 2, which is 5. Okay, so I'm getting what? I'm getting 6 divided by 8, and I'm getting 4 divided by 5. Are they equal? Okay, let's figure this out. So let's do factoring. Let's factor 6. If I factor 6, I'm going to get 2 times 3, and I'm going to go 2 times 4, and I can cancel the 2's because these are the common factor, and I have 3 over 4. So actually 6 divided by 8 is actually 3 divided by 4. So this is the correct answer. So that means this is obviously not correct, and we cannot cancel this 2. Okay, so the 2 is being multiplied, but we cannot cancel them because this quantity is being added with this 2. Same thing here, 3 times 2 is being added with 2. Now consider this 2 as this x. Okay, let's say our x is actually 2. So let's say the x is 2. If we do that, can we cancel this x? Let's say 2 times x and 5 times x. Can we cancel them? We cannot cancel the x's, even though the 2 times x, this is being multiplied, but still we cannot cancel them because you can see this is being added with 6. We can't cancel them. Okay, and this is the proof where I showed that 6 divided by 8, 2 times 2, 3 times 2, and 2 cannot be cancelled because you're going to get something completely different, which is 4 divided by 5. We cannot do that. Okay. All right, I hope this makes sense. So how do I simplify this? So let's erase this and let's write this again. 2x plus 6 and divided by 5x plus 15. Okay, so we will factor 2x plus 6 and 5x plus 15 separately. So first let's factor 2x plus 6. I think you guys already know how to factor this, so I'm not going to show. Just write it. So this is 2x plus 3, and then I'm going to do 5x plus 3. Now what are the common factors? The denominator and the numerator. So here are 2 times x plus 3. So 2 times x plus 3 and 5 times x plus 3. So I can safely cancel x plus 3 and x plus 3, which will produce 1. And I'm going to get 2 divided by 5. Okay, so that's how it works. Okay, so now let's look at one more example, and then we can start working on the handout. So let's erase this and let's do 5x plus 10 divided by 15x plus 20. Once again, we cannot cancel the x, right? And you already know why. So let's not do that. So let's factor 5x plus 10. If we do that, I'm going to get x plus 2. And if I do this, I'm going to do 5x plus, 3x plus 4. Okay. Okay, so factor this properly, you'll get this. So now I cannot cancel x plus 2 or 3x plus 4, or I cannot cancel this x and x. Okay, you already know why. So I can cancel the 5 and 5 because there are the common factors. So cancel this and we are left with x plus 2 and 3x plus 4. Okay, so that's how we divide polynomials. So make sure, if you are still not 100% sure, please watch the video one more time. I think that'll help you. Alright guys, thanks for watching and I'll see you later. Bye.